Dropbox physics. Materials, specific heat capacity. Okay. Let's begin. What about Gao? Where's Gao? Don't know. I mean, she's in today? Oh yeah, of course. I saw her earlier. Ah, it's okay. It's okay. It just. Do you want to send the message? Is it?
Yeah.
Okay. Okay. What are you saying? Where are you?
Summer said okay. Maybe just half me. Let's go.
Yeah. Don't worry, Ben. Thanks for checking. Ben, it's okay. It's okay, Ben. Thanks for checking. Right, can you write this down? Specific heat capacity. Fairly tired. Summer. Specific heat capacity.
Go missed her bus. So maybe he'll be late for 20 minutes.
But Gao lives in Rialto.
Yeah, she missed her.
Okay. Okay, fine.
Yeah.
Okay. You got this specific heat capacity?
Yeah.
Okay. So, not a lot. Why does metal feel colder than plastic? Or another question. Okay. Why does water at 10 Celsius feel colder than air at 1 Celsius? So if you were in water at 10 Celsius, or if you were in air at 1 Celsius, the water would feel...
Density.
Density is one reason, yeah. In fact, Ben, there are many reasons.
How to say?
Yeah.
Liquid and gas.
Yeah.
Is different.
Yeah, it's true, because one's a liquid and one's a gas. So the point is, temperature is not enough. There's more to study. We need another way to talk about heat and temperature. For example, metals will feel hotter sooner than plastics. So if you have some heat and you have metal and you have plastic, which gets hotter quicker? The metal gets hotter quicker. The plastic gets hot slowly. Yeah? What's different between metal and plastic? Maybe you did this in chemistry. Metal is a watt and plastic is a watt. What's different between metal and plastic? One is a... Metal is a... Is a what?
What?
Well, I don't know. Metal is a conductor. Do you know this word? Do you know this word? And plastic is an insulator.
Oh, I don't know.
Okay, fine. You will do this in chemistry. In fact, conductors will feel hotter than plastics. some materials warm up faster than others. Why is this? So, for example, my coffee, I have to put a lot of heat into this to make it hot. Okay?
Yes.
But my tea, I only have to put a little heat into this and it will feel hot quite quickly. So this gives us our first definition. We have this thing called specific heat capacity. And what it is how much energy you need if you have 1 kilogram and you want to make it 1 degree hotter. Okay, so for example, this table is made of wood. If I have 1 kilogram of wood and I want to make it 1 degree hotter, you know, maybe go from 20C to 21C, how much energy do I need? That's called specific heat capacity. Or if I have 1 kilogram of water and I want to make it go from 30C to 31C, or 40 to 41, or 52 to 53, how much energy do I need? I need C energy. And it's different for each material. So what materials do you think have a big value of C, a very high specific heat capacity? What materials do you think need lots of energy to get hot?
What is C?
That's what I'm explaining. No, you're confused. Okay, Ben? My question is, what materials do you think have a big specific heat capacity? That is, what materials need lots of energy to get hot? What do you think?
Gold.
Yep. No, it needs no. Gold needs a little energy to get hot. Yeah.
Diamond.
Diamond is more.
Yes, I think so. What else? Keep it simple though. Simple material.
Gold.
Plastic.
Plastic is
Plastic needs a lot of energy to get hot.
is plastic,
This is plastic.
but on like bag.
Yeah, but you need to picture 1 kilogram. If you had 1 kilogram of plastic, that needs a lot of energy.
Is
Yeah, yeah. What about if you had 1 kilogram of gold? That needs a little energy.
Glass.
1 kilogram of glass probably needs a lot of energy. Depends on the material. So, what about a material like wood? Needs high energy to get hot. Yeah? Okay. So, in a moment I'll give you different values for different materials. Okay? Before we continue, you need this definition for the exam. Now, before you write it down, if you want, instead of saying 1 unit, you could say 1 kilogram of mass. And instead of saying 1 unit, if you want, you can say 1 degree Kelvin. 1 Kelvin if you want. It's up to you. Do you write this down somewhere, please? Oh, who's texting you? Is it Go?
No, they are talking in the WhatsApp.
Okay, well,
Sorry.
put the phone away.
Okay.
You know, the other teachers were telling me you use your phone a lot in class.
Maybe.
Maybe.
I know who is she. Yeah.
Do you know who she is?
Yeah.
Yeah,
I know.
yeah, I think so.
Yeah.
Maybe you make her very angry. That's true,
Yeah,
isn't
that's
bad?
true,
Yeah,
that's
okay.
true. Yeah.
Okay. You have this, Khalifa? Yeah. Did you write exactly like this? Or did you make it?
Yes,
Yeah.
exactly.
Okay.
I'm not sure. You will
On Friday?
Last week is.
Yeah.
But this week, I don't know it's Friday or Wednesday because in the first episode, you tell us it's Wednesday week.
Yeah.
But last week it's changed, and I don't know it's changed to Friday or just 1 week.
You'll have to ask Neil. What I think is I have you on Friday
It's Friday.
for physics support
In
Every-
4
every Friday
in 4 o'clock
at 4 o'clock.
or
Yeah.
at
And
4 o'clock.
chemistry.
Is the other lesson maybe on Wednesday? I don't know.
Friday? On Friday, the timetable says done.
When do you have me?
That after today is
No, it's not cancelled.
Tomorrow.
It says my name.
Yeah. Stephanie, yeah, tomorrow. Wednesday, tomorrow.
Oh,
After maths.
Okay.
45.
Okay. No, I tell you what. I'll check. Did Neil say you have me tomorrow?
No, but
Now-
the timetable says.
Okay, well, maybe it changed. If you have me, you have me. You know, it's not like, what time is it at?
The same time. From 3 to 5.
No, that's physics. That's normal class.
Oh,
We're talking about assessment support. No, I think I said everyone Friday. Okay, continue.
Okay.
Right, let's look at the units. So, guys, let's look at the units here. You have 1 kilogram. Ben, please, I'm so tired. Help me by listening. Okay, maybe you should put your phone in your pocket like Summer. Go on. In your pocket. What? No, your phone.
Yeah. Charging.
Okay, fine. Fine. Go on. Thank you. Okay, so you have 1 kilogram and you want to make it hotter by 1 Kelvin or 1 Celsius. So the C is how much energy you need.
Mm.
So what are the units? Well, it's definitely going to be joules, but it's joules per kilogram per Kelvin. So you could write it like this. Okay?
So joules kilogram per Kelvin.
Yeah.
3.
3?
3.
3, yeah. That's the C,
Okay.
the units,
It's a new lesson?
of course.
So, I was waiting for the boss.
I heard. Okay, you wrote this down? Now, we can use this to get a formula. The energy required to make m kilograms delta T hotter can be found from this formula. Okay, now again, let me just explain. You have m kilograms, and you want to make the temperature an extra delta theta hotter. Okay, so the energy you need to do this, the delta Q, is equal to mc delta theta. Okay, this is the heat energy required to make m kilograms delta theta hotter, and the C is specific heat capacity of the material, and it's different for each material. Okay, so if you can write this definition down now, please. This is our formula for today.
The lesson that I missed, there's no video on YouTube.
Are you sure?
Yeah.
What lesson did you miss?
The Eddie Gus,
Yeah.
There's no video?
No video.
the 2 lessons, I think.
Let me see. Uploads. What's it called?
Eddie Gus. Just last week, I think.
Ideal gas.
There's no this one.
There, physics 1819 intake 1.
Yeah, but
Intake
not
2.
in YouTube.
Are you sure it's not on YouTube?
No.
Did you search my channel?
Ouch.
I don't believe you. I'll
Did you search?
I search in the class end.
It's there.
I search when the class end.
Okay, open up Moodle. Open up Moodle.
Oh.
Moodle.
Oh, there's on Moodle?
There should be a link on Moodle.
I just opened YouTube.
Yeah.
I follow you.
Yeah, yeah.
Yeah.
Yeah. Have you got Moodle?
Huh?
It's on YouTube?
God, it's impossible. Cause I said
No, it's not impossible.
no, cause I said
You sent it in 18 hours ago.
Yeah.
And it's not
So
the
last one.
class finished.
so it's
Last week you didn't send this
Okay,
to YouTube. I searched it.
okay. No, but I did, but
Yeah,
sometime
yeah.
maybe YouTube delay.
Yeah. Oh.
okay. Yeah, maybe.
Yeah. Because you see me, I upload every lesson.
Yeah.
At the end.
But this just
Well, you send an email to YouTube. You say, Dear Mr. YouTube,
yeah.
please go faster with Stephen's videos. Okay?
Okay.
Thank you.
And the YouTube will remind me when you upload.
Yeah. Okay, you got this definition? You're right. Yeah, continue. Yeah.
Theta.
Yeah.
Delta theta
Yeah.
is
Change in
of
temperature, yeah.
and delta Q.
Energy.
Oh, so C is this
Yeah.
capacity.
Yeah. Specific heat capacity. Hmm.
So the M kilo is without M though too.
No, just one.
No, just M.
Yes.
So the weight of the
Required to
Yeah.
increase M kilogram.
It means you have M kilograms. You want to make it hotter. How much energy do you need? Continue. Now I'm going to give you some values. Okay, so the first one is water. Water specific heat capacity is 4,181 joules. You know this, but just think about what I'm saying here, okay? If I have 1 kilogram of water and I want to make it 1 Kelvin hotter, I need this much energy. That's how much energy I need. Okay, that's a lot of energy. It's a lot, actually. Next is solid water. You know, ice. That's actually different. That's only 2,110. Yeah?
Yeah.
The next one is steam. It's 2,080.
Oh, steam.
Not the game. No.
No, it's not a game.
I know it.
Yeah.
Gaming system.
Yeah.
I know it's
Yeah.
not a game. I have it at home.
Oh.
Of course I know.
Oh.
Yes.
Oh.
Yes.
Add friend, please.
Maybe I don't want to. Okay. Next is copper. Do you know this material? Cu, yeah. It's a metal. Now it's quite small, you see, it's only 385. Next is milk. I just put milk in for fun. It's 2,850. Yeah. Next one is alcohol, 2,300. Okay. Lead. Do you know lead?
Yeah,
What's the symbol? What's the symbol for lead in chemistry?
pH.
Nope, not pH.
PB.
What? Say again?
PB.
PB. Yeah. It's lead.
Yeah.
And the last one is air. 1,012. Okay, you got those values? Go? You have those? What are you checking on your phone? What word? Okay. You guys, don't use your dictionary so much, you know?
Actually, I just guess what is Chinese.
Yeah, that's better than using your dictionary.
Actually, I guess right.
Good. That's good. You know, because if you try to guess it before you use the dictionary, then you'll remember it. Yeah? What?
What's the meaning in Chinese?
No, don't say it. You won't help him if you tell him. It's better if he figures it out himself. Yeah? It's better for you, right? Okay. Why do different materials have different heat capacities? It's complicated, and we might look at it later. Okay. Here's an example. How long would it take to boil enough water to make a cup of tea by using a small 1 kilowatt electric kettle? So we'll do this one together, okay? The only information I tell you is that the power of the kettle is 1,000 watts. It's 1 kilowatt. Okay?
What?
Yeah? Don't tell me you forgot this.
I know this, but
Yeah.
how to spell for
Aha. W-A-T-T. Yeah. Not W-H-A-T. Right. What is the formula for power?
WT.
W
Per T.
per T, over T. No, English only. English only. What are you going to ask him?
which lesson I did for power?
Don't say anything.
No pass.
Here.
Power and
Efficiency.
efficiency. E equals little per.
Yeah. Can I continue, go?
Yeah.
Yeah, you forgot this. So, I'm looking for the T. T equals W over P. Yep?
Okay.
So T equals W over 1,000. Okay? Now what is the work I'm doing? No, don't worry about it, Go. Just listen to this question, please. Please.
Work is
Yeah.
MC delta.
Very good, Ben. MC delta theta is the work over 1,000.
Yeah.
Okay, now look, we'll do this one together. We'll just pick up the numbers. I want to make a cup of tea. So what do you think the M should be?
Mass.
Yeah, but like what value? If I want to make a cup of tea.
60 gram.
Ah, that's a small cup of tea. Come on, Summer,
One-
go. Yeah?
1 liter.
1 litre. 1 litre might be too much for one. No, that's fine, that's fine.
0.25 liter.
Ah, nobody puts 2.20. No, you wouldn't put this in a kettle. I think you would put in at least 0.5 kilograms, at least, in a kettle.
Yeah.
Because 0.25 is only like this much.
Yeah.
You would pour this much in a kettle and turn the kettle on.
Okay.
Would you?
I will.
Okay.
Yeah.
Alright, if you say so.
Yeah.
C is 4181.
Oh yeah.
Now, what is the delta theta here?
Is
380.
You can use Celsius. You can use Celsius.
100.
No,
18.
80.
Like 18
Yeah.
or
Yeah, like 80. Ben, explain why it's 80 and not 100.
because water.
Because of the sea,
No.
the sea higher.
I don't know.
The boil point is different.
No. No, Ben, try to explain. It's good for your English. Try to explain. Now listen carefully.
Okay.
Like if you want to boil in the water, but this water normally temperature is like 20.
Mm-hmm. Mm-hmm.
Yeah.
Yeah.
Oh.
You see, normally the temperature is 20,
Yeah.
maybe, and you're trying to take it to
To
100. So the
100.
delta
The
theta
is
80.
Yeah.
I think though, Ben, maybe it's more like 90. When it comes out at the top, it's maybe like 10.
Yeah.
Okay, over 1000. Okay, calculate this please. Let's get the time.
One hundred 88.145.
128.
We won't worry about that, okay? So that is about 3 minutes 8 seconds. So it'll take you about 3 minutes to make the kettle boil. Which, you know, seems right. Yeah? It seems believable. Okay? Alright, this is our first example. We'll continue now. Do you want to write this down?
Question, please.
Yeah.
Question.
Oh! Well, it's not really, it's more of a made up question. The question is, you want to make a cup of tea, how long will it take? So here I wrote, how long will it take to boil enough water to make a cup of tea by using a small 1 kilowatt electric kettle? But you could have just, Khalifa, you could have just said, how long to make tea? You know, because we made up some of the numbers for our example.
I think you can add oil specific heat capacity.
Oil specific heat capacity? I don't know what it is, I'll have to check Google. Is it big or small, do you think? Bigger than water? Are you sure?
Oil?
Yeah,
It's small.
I think it's small. Well,
If you cook, you will know it's small.
well, I mean, but if you heat oil,
Yeah.
it doesn't heat very quickly, does it?
It's
Like how
very
long would it
quick.
take? How many
Uh,
minutes? Just 1 minute?
So
Yeah.
it depends on the.
Depends on the heat, the pressure of the fire. Like the heat.
Yeah, no, I know, but... Okay, why don't you check heat capacity of cooking oil? See what it says. Did you write this down, Bill?
Does it related with the mass oil and water in comparison? So maybe we will boil 1 kettle of water, but we won't boil that much.
Yeah, that's true, because the formula has M in it. So smaller m means smaller time.
We usually just little bit older.
A little bit, yeah, but I mean, like, if you have like for making chips,
1.67 to
Oh,
2.5.
it's small.
Small.
kilo joules?
Yeah.
So that's like 1,600.
Yeah.
So that's 1,600. What?
1,700.
1,700?
No, 1,600. Yeah, 1,600.
So that's around about the same as it's less than milk,
Yeah.
you know. Okay. Right. I'm going to give you one to try. It's very similar to what I just did. Look. What are you checking? The value? 100 grams of ice is at -10. How much energy do you need to increase from -10 to -1? Okay, calculate that. Use the formula. Good, yeah. Yeah. You got an answer, Ben?
What's the unit for cube?
For what?
Cube.
Joules.
Oh, it's energy.
Yes. You break my heart.
1899.
1899 about? Roughly. Yeah. So what's the M?
Uh,
0.1. The C?
2110.
200.
And the delta theta?
9.
9. Okay. An electric heater has a power of 3 kilowatts and it's used to heat a room. The room is 10 by 10 by 5. The room is 10 Celsius and you would like the room to be 20 Celsius. The density of air is about 1 kilogram per meter cubed. How long would it take to heat the room? I'll draw the picture for you, okay? So what you have a room, and of course the room is full of air, and the density of air is 1 kilogram per meter cubed. Okay. The room size is 10 by 10 by 5 meters cubed. The size of the room. Okay. And then the other thing I tell you is that there is an electric heater here. This heats the room. The power of the heater is 3,000 watts. And lastly, what I tell you is the temperature is 20 Celsius. Sorry, the temperature is 10 Celsius. Okay? And you would like the temperature to be 20 Celsius. Do you see all the information?
what's the question?
So the question is, how long, what is the time it will take the heater to heat the room? So, you see this is a lot like the question with the cup of tea. Yeah? Good, yeah.
It's kilogram.
Yeah. Too big.
It's air in
what's this?
This.
No. In-
This.
No.
This.
It's 5?
This.
Yeah.
5.
Okay.
What do you think it is? S?
Yeah.
Oh, 5.
Hmm.
28 meters. 28 minutes.
I'm not sure.
Yeah, okay, 28 minutes sounds fine. Yeah, that sounds fine. Let's calculate. So what formula did you use? Power equals work over time. Yeah? So time equals work over power equals mc delta theta over power. Right? Do you know the m? You don't, well, you don't at the beginning. You can use this formula. Rho equals m over v. So this becomes rho vc delta theta over p. Okay, so what's the rho? 1.
1.
What's the v? 500.
500.
What's the c?
1 0 1 2.
1 0 1 2. What's the delta theta? 10. And what's the power? 3000.
Yeah.
Okay, so what do we get for the time here? You said 28 minutes?
1686.
28 minutes. Yeah? Yeah?
Yeah.
What's wrong, Summer?
In the morning, I break this
Ah, okay. Sore?
pain.
Pain.
A lot of pain. Yeah.
Now you know how you make me feel.
Why?
The pain of the neck
Yeah, exactly.
means annoying.
It's English expression.
Okay.
You know this one.
Yeah.
You heard it from your uncle, maybe. All right. Continue.
I
What's wrong?
like
Huh?
I feel
Yeah, what? I.
Which one I can say?
Yeah, what are you saying?
she said the sentence like it's
Yeah.
It's Islam.
you say it's grandfather says
Uncle says it. Yeah. Yeah. It's do you mean like an insult? No. Slang.
Which one is it?
yeah.
Slam.
Slang. Yeah. Yeah. Pain in the neck. That means you make me angry. Okay. Yeah.
Why? Why?
Right.
Or you upset you.
Yeah. Yeah. Okay. I'll do this one. So watch carefully. A physics student is making a latte. He mixes 200 grams of hot milk at 27 Celsius to 50 grams of hot coffee at 80 Celsius. Approximate coffee as water. So imagine coffee is like water. It's not, but it's, it's like water. What is the final temperature? So just to draw the picture, what you have here, you have some milk and you have some coffee and you mix it together. Okay? How much milk do I have? I have 200 grams. And how much coffee do I have? 50 grams. And the milk's temperature is 27. And the coffee's temperature is 80. So then, of course, these mix together. And here's your coffee. The final temperature won't be 80, will it? That's too hot. It won't be 27. It'll be somewhere in between. And I want to calculate this now. So let's do this together. Okay. So this is how you picture it. What will happen to the coffee? Will it get hotter or colder?
Colder.
Colder. And what will happen to the milk?
Hotter.
It'll get hotter. In fact, conservation of energy, remember this, means that the energy this guy gets must come from this one. Do you understand?
Yeah.
So what you can say is the energy lost by the coffee equals the energy gained by the milk. Does that make sense? Okay, so let's calculate. Oh, and by the way, we'll call the final temperature here and here, we'll say it's X Celsius. Okay, so what's the M for the coffee?
0.05.
Okay, and what's the C?
4181.
4181. Now, what's the delta theta? And I should help you out by saying X,
Minus
Minus
80 minus X. Good. Equals M. What's the M for the milk? 0.2. And the C?
Copy.
2850.
2850.
Yeah.
And the delta theta?
27.
Yes.
X minus 27.
X minus 27. Because X is bigger than 27.
Yeah.
We want to keep it all positive.
Yeah.
Okay. Now, this is just a maths problem. We want to solve for X.
Yeah.
Off you go. Give me the X. Yes. I'll give you a little tip to make this quicker, guys. If you want to make this quicker,
Oh.
I would multiply these two numbers and divide by these two numbers. So now it's only one number. It's quicker. So you can get 80 minus X equals some number times X minus 27. Be strong, Summer. Be strong.
Okay. I want.
Thank you.
I want that.
You say that number.
The 2 on the right divided by the 2 on the left can give you one number.
It's not pretty good.
Yeah, no. That's fine. 2.2.
2.7.
That's this number here.
Yeah.
Yeah, okay, fine. 80 minus X equals 2.77776.
Just 7.
2.7266.
2.7.
2, 3. Yeah.
Yeah, but give me 3 numbers here.
2.726. 7.
2726.
2727.
2727.
Yeah,
Okay.
yeah.
Okay. So now you guys have to solve 80 minus X equals 2.727X minus 27 times 2.727. So you now have 3.727X equals 80 plus 27 times 2.727. So now you get the answer. X is 80 plus...
1.709.
No, impossible.
It's 41.
Thank you.
Oh, it's far.
What is it, Ben?
41.4.
Is that right? Yeah, that looks right. Yeah, I think so.
it's wrong.
We can.
Yeah, well, I trust Ben.
You don't trust me.
Not much.
I know why.
Why?
Because
Maybe.
yeah.
Okay, is this one, did you write this one down? Yeah? This, by the way, guys, this question where you have to mix two things, that's common.
Should be
It's not 41.4?
1.42.
41.2? Close enough. Wait, I know. About 41. What? More?
Can you go up? No. The whole. Oh yeah. This one.
oh
727.
No.
Not 7. Not 277. 727.
2.2.
Yes.
Yeah. Yes. That's right.
727. Not 227.
727.
What is it then?
Fine, it's fine.
45?
No, 41. It's fine.
41 is fine? Okay, fine. Okay, you wrote this down? Yeah? Okay. Oh, sorry. You got this, Ben? So, last one here. I'll do this one. So here's the last one here, and then I'll let you try for a few minutes. Here's the wall, and you have here a 10 gram lead PB bullet from a gun, and it's going 100 meters per second, and it will hit the wall, and the bullet will be warmer when it hits the wall, because what happens is here it has kinetic energy. Here, does it have kinetic energy? No, because it stopped. It hit the wall, right? What happened to the kinetic energy? It became the heat energy. It converted. Yeah? So, let's calculate the temperature. A half m v squared equals m c delta theta. What is the c for lead? 129, is it?
1012.
No, for lead. 129. I was right.
Yeah.
Oh, you must have wrote it
so
down
sorry,
wrong somewhere.
I wrote it
Right.
down.
So, what's the delta theta here? Well, hang on, they cancel, don't they? And that would be 10000 over 2 over 129. Yeah? So that's 5,000 over 129. What's that, please?
Three, 8.7, 5, 6.
So, for example, if the bullet begins at 10 Celsius, when it hits the wall, it will be 48 Celsius. Yeah, isn't it? It gets quite hot when it hits the wall. Yeah. Okay. Good. Write this one down, and then only for about 5 minutes, I want you to try some of the homework. Okay. Where's the book? Physics book.
The bullet is lead.
Yeah. Well, old bullets are, not new bullets.
Oh.
I think new bullets are made of something else, Ben.
Can't solve some question for this.
Which one can't you solve?
5 and 6.
Yeah, they're hard, huh? We can do that in the tutorial then next week.
Next week.
Yeah, we had a tutorial this week. Yesterday we did ideal gas law, remember?
Yeah.
Because you didn't do it at home. Okay. Right. Just 5 minutes practice these questions. If you could do like 1 and 2 now, that'd be great, please. 1 and 2. Hmm?
I was absent for the power and efficiency.
Now you see what happens?
Yeah, and the midterm exam, there's one question for this I didn't solve.
Yeah, and now you need to watch the lesson.